The directions for these problems is to condense the following logarithms into a single logarithm and then simplify if possible. So for this first one, we have log base 10 of 20 plus log base 10 of 50. Remember, addition, though, between two logarithms does not mean our adding that we knew back in second grade. This is adding using logarithms, which means when I condense, we're going to condense it to 20 times 50. Remember, addition between logarithms means multiplication within a logarithm. So this is log base 10 of, and this will work out to 1,000. And because there's all numbers in here in this argument, we want to see if it can be simplified. So 10 to what power gives me back 1,000. And if you know it, go ahead and write it down. If you don't, then use your calculator because it's base 10. You just simply type in log 1,000. You're going to come up just the number 3. We'll jump over here to the letter E. Log of this minus, that means I'm going to have a division bar in my answer, log of that. So it's still log base 10, and I'm condensing. There's no powers to pull up. Actually, that would be one of the first things we do, because we're kind of going in the reverse order of what we did on the previous page. Remember, we pull the powers down, and then we were done. If we're going backwards, we'd pull the powers up and then start making it into one log. So we're going to start with one logarithm. I do have a subtraction symbol, so I'm going to have a division bar in my argument. On top goes the x minus 3. And on the bottom, the 2x minus 5. And that's it. All right, let's take a look at letter B. This one has a plus sign in between two logarithms, no powers to pull up. So I'm going to go ahead and write it as natural log of, and then because it's plus, it's going to be multiplication between the two arguments. So 2x plus 3 times x minus 1. Now here we can do a little simplifying. If you remember the FOIL method, first, outside, inside, last, and then combine like terms. So this is going to be natural log of 2x times x, 2x times negative 1. All right, so we took care of the 2x. Now multiply by positive 3 through that parenthesis grouping. So plus 3x minus 3. Combined up your like terms, and then you're done. So the 2x squared, there's no other squareds in the problem. Minus 2 plus 3, that's going to be a plus 1x, or just plus x, and then minus 3. And that's simplified. For letter F, I see that there is a number in front of a logarithm. In order for me to make this into one natural log, I can't have a number in front of the natural log. They all have to have the same ln, ln, ln. So the 2's got to go. So we're going to move the 2 up to the power position. And now they're all natural logs. And then I do see a subtraction symbol here, so I am going to have a division bar in here. And now it's a matter of just placing the argument. Should it be on top or should it be on the bottom? And what determines that is if it's positive or negative in front of the logarithm. So if it's positive, it goes on top. If it's negative in front, it goes on the bottom. Positive, top. Notice no symbol in between. It's just multiplication up there. But you don't put a plus sign. The plus tells me it goes top side. Now this can be simplified as well. Another name for 10/5. 5 will divide into both of those, so that'll work out to 2x squared. Okay. Next one, Letter C here, we've got a bunch of numbers in front of the log base 2's, so all those have to move up. So minus log base 2 of y to the 4th. And then log base 2 of z to the 1/2 power. So guess what's going to happen there? If it's a fraction power, it can also be rewritten as a radical. So we'll do that in just a second. Now that they're all log base 2's, write you down one big log base 2, parenthesis, and then put your argument in. If there's a minus sign, we're going to have a division bar. And then just place them. X cubed, top side. Y to the 4th, down below. Z to the 1/2, top side. But I'm not going to write it as z to the 1/2. I'm going to finish it off by calling it the square root of z. All fractional exponents, remember, can be written as radicals. For letter G, I don't have just ln, so I've got to move the numbers up. Move them up to the power position there, so natural log of 7 squared plus natural log of 2 cubed. Now I can make one natural log, 7 squared times 2 cubed. And those are numbers that you can just multiply together. 49 times 8 is going to be the natural log of 392. That's not going to simplify nicely. It'll be a big long decimal, so leave it as an exact answer. For letter D, no powers to pull up, so let's just leave it as log base 10 of, and then put in x plus 2 times x minus 5. And then FOIL that out. Some of you can do the FOIL in your head. If you can, that's great. If you need to write in all the steps, that's okay too. X times x, x squared. X times negative 5, 2 times x, 2 times negative 5. So we have log base 10 of x squared minus 3x, negative 5, positive 2, and then a minus 10. Last one of this group, powers need to go up. I see a fraction, which means a radical, and it's going to be a cube root because it's a 3 down there. And then the last one, z plus 2 cubed. Now that I have all natural logs or the same logarithm in front here, it can be condensed to one natural log, parentheses. And then I do have a subtraction, so there's going to be a division bar. If these were both subtractions, then both things would go down below. And in this case, there's just the one subtraction, so the z plus 2 cubed goes down below, and then these guys on top. X squared, y to the 1/3. It's not really necessary to FOIL the z plus 2 times z plus 2 times z plus 2 out. We'll just leave it like this. And remember, you can't just cube the z and cube the 2 because of the addition sign. You would actually have to do some serious FOILing on that. We're just going to leave it alone. The last ones in this example on this page go back to some properties that we talked about earlier. You might want to recall these. We had log base a of a to the x was just x. We said if the bases were the same, they sort of cancel each other out. And then the other one was a raised to the log base a of x was also just x. So for letter A here, without using your calculator, this is really log base 10 of 10 to the 12 the answer is 12 by using this property right here. Log base 10 of 10 to the whatever equals whatever. Letter D. ln, remember, is log base e of e to the x plus 5. So again, the bases are the same. It's falling under this same rule here. My answer is going to be the power, x plus 5. Letter B, log base 3 of 3 to the 4. Simple enough. The next 3 is where it gets a little trickier. 10, log base 10 of 3 would just be 3, but there's this plus log base 10 of 5 attached. So we need to make it into one logarithm like we have here up in the numerator. So I need to condense these two logs into one. So when you add logs, remember when you make it into one logarithm, it's multiplication. So this is really 10 raised to the log base 10 of, no subtraction, so this is all multiplication, 3 times 5. Or 10 raised to the log base 10 of 15, which turns out to be 15 by our property up here. Same idea for letter C. There can't be a number in front of the logarithm. It's got to be just a raised to a log base a, not two log base a's. So if there's a number in front, we're going to pull the number up to the power position, e. ln is log base e of 7 squared. Well, 7 squared is 49. So again, using our property right here, a to the log base a of x is x, e to the log base e of 49 is 49. Last one, too many logarithms up here in the exponent, so I need to add them together. So this is going to be 7 raised to the log base 7 of, and the tricky thing is, again, it's not 10 plus 5. We're not doing our addition when we're talking about logarithms here. It's multiplying within the argument. So 10 times 5, or 50. And then following our little formula here, a to the log base a of x is x. 7 to the log base 7 of 50 is 50.